Welcome back to Aurora Tech Channel. Today, I'm reviewing another tool changer, the FlashForge Creator 5. When it comes to tool changers in 3D printing, before the Snapmaker U1 was released last September, we only had DIY options or the Prusa XL 5 toolhead version, which cost around $4,000. Once Snapmaker released a machine based on a similar concept to the Prusa XL, but with a lot of refinement and a price below $1,000, it changed a lot in the 3D printing market. Now we have another affordable tool changer from FlashForge, the Creator 5, priced slightly lower at $799. So let's take a look at what this machine offers. The print volume is the same as standard Bamboo Lab machines at 256 by 256 by 256 millimeters, which is about 15% smaller than the Snapmaker U1. The table space required is about 22 inches or 560 millimeters by 20 inches or 500 millimeters, with a height clearance of about 28 inches or 720 millimeters to allow for the Bowden tubes and cables on top. The machine weighs 30 pounds or 14 kilograms. It is an open frame machine, while FlashForge also offers a fully enclosed version, the Creator 5 Pro. The motion system is Core XY, with a linear rail on the X-axis and linear rods on the Y-axis. The Z-axis is supported by 3 rods and lead screws. All filament spools are mounted on the right side of the machine. There is no RFID reader or motorized automatic filament loading and unloading, so you have to push the filament all the way into the extruder manually, just like on the Prusa XL. The toolhead housing is injection molded, and the cabling is simplified into a single USB-C CAN bus connection. The tool changing time is about 7 seconds, and we will do thousands of tool changes to test the reliability. The maximum nozzle temperature is 320 degrees Celsius, and the bed temperature goes up to 120 degrees Celsius. The print surface is a double-sided textured PEI sheet, the touchscreen is 4 inches, and the machine also comes with LED lighting and a built-in HD camera. The firmware runs on Clipper, and the slicer is a skinned version of Orca Slicer. Cloud service is optional, but I will just use the printer on my local network. I would like to thank FlashForge for sending us this early pre-production unit to review and for sponsoring today's video. As far as I know, the hardware should be the same as the mass production units. The only difference will probably be the firmware, with more bug fixes in later batches. As always, we won't hold back from pointing out the cons and all the issues we may find during testing. With that said, let's get started. The machine came in a relatively compact box. The inner foam protected it very well. The whole machine is placed inside a large, thick plastic bag, and everything can be lifted out in one piece. The parts and accessories are all packed inside the machine. Besides the machine, we have a set of 4 print heads, spool holders, the screen, some cables, and accessories. The assembly should be pretty straightforward. We will start with the screen. Unlike most screens that need a cable attached, this one uses a slot-type connector that can simply snap into place without guessing the direction. Then we will rotate it to the right side, which is where we mount the tool heads. First, we need to install 4 nozzle ooze stoppers, then rotate it 180 degrees to mount the tool head controller board on the outside. Then we can flip it back and snap on all 4 tool heads one by one. After that, connect the cable to the X carriage. Unlock the bed by loosening 3 screws. The one you need to loosen is the middle screw, and it would be better if FlashForge put stickers on them in the final production units. Then, we can install the spool holders. The holes are all covered by labels that need to be peeled off. These spool holders are just simple plastic ones without any spring-loaded mechanism, unlike the Snapmaker U1 or Bamboo Lab A series. Finally, we can connect the power and turn on the machine. Starting with language selection, it will then show all the nearby 2.4 and 5 GHz networks. Enter your password and connect to your network. For the cloud, I will just skip it and use the machine locally. It's going to run a self-test and calibration, which will take about 40 minutes. It starts with homing, followed by bed leveling. It's going to do a 10 by 10 grid with 100 points of leveling. Since the X carriage is not grabbing any tool head yet, it has its own dummy nozzle just for leveling. After that, it will run input shaping. finally, we have to remove the print surface, as it will use the alignment disc on the bed for tool head offset calibration. It starts with the dummy nozzle, then it's going to grab the first tool head and probe around the disc for X, Y, and Z offset calibration. It will do the same for all 4 tool heads. Okay, the printer is now ready. As you can see, the LED light that came with the machine keeps flashing on camera. You won't notice it with your eyes, but this flashing LED in my footage is kind of annoying, so I will turn it off and use my own lighting to continue filming. I will now load some filaments. Unlike the SnapMaker U1, which has motors to load filament automatically, this machine uses a simple approach like the Prusa XL, which requires you to push the filament manually into the print head. It doesn't seem to have RFID, but since I use random brands of filament, I will simply select the filament type and color on the screen. I will do the same and load all 4 colors. Now, we can go to the slicer and start our first test. It's another skinned Orca slicer. Since this machine is pretty new and there is no profile in Orca Slicer, I am not sure if FlashForge is going to add one, and I hope they will. But for now, I will keep testing with this skinned Orca slicer. The default print speed is set to a maximum of 300 millimeters per second for the inner wall and infill, which is pretty fast. The acceleration is set to a maximum of 10,000 millimeters per second squared. It's not the fastest, but it should be in line with most other new generation high-speed printers. I will start with this 4-color square. As you can see, all 4 colors appear in every layer. On a single toolhead AMS style setup, this print is going to take 2 to 3 hours. For a tool changer like the Prusa XL and SnapMaker U1, it would take about 30 minutes. And the estimated time for the Creator 5 is 28 minutes. I just sent the print directly from the slicer to the printer over my local network. I also selected bed leveling. One thing I didn't expect is that it relevels the whole bed and probes 100 points, which is completely unnecessary. I would expect it to just probe the printing area, and I hope FlashForge will fix this in future firmware. Once the print started, I checked the tool changing time. It took about 7 seconds. You may hear that squeaky sound when the tool head moves rapidly. In later tests, I didn't hear it anymore, so I just consider that a hiccup during break-in. Once again, it took about 7 seconds, with the same squeaky sound when the print head traveled at high speed to the prime tower. Let's time it one more time. It seems the tool head change time is very consistent, and all changes took about 7 seconds. The print finished in 28 minutes, not including prep time. The model itself uses 5 grams, and the prime tower uses 4 grams, closely matching the slicer estimate. Let's compare this print with other printers, starting with some tool changers and hot-end changers. When compared to the Bambu Lab H2C, the total filament usage is similar, as the H2C also produces almost no poop waste, except during the initial filament loading. Since the H2C requires about 30 seconds to change the hot end, while the Creator 5 only requires 7 seconds, the Creator 5 is much faster, about 2 times faster than the H2C. When compared to other tool changers like the SnapMaker U1 and Prusa XL, the Creator 5 is marginally faster, and the filament usage of all 4 machines is similar. We will then compare it with dual nozzle and single nozzle AMS style setups. When compared to the Bambu Lab X2D, a tool changer saves all 14 grams of purge waste and prints 3 times faster. When compared to a single nozzle AMS setup like the Bambu Lab A1 and Creality Spark X i7, it prints 4 to 5 times faster and also saves 4 to 5 times the filament when printing the same model. It's obvious that tool changers are more effective for multicolor printing in terms of both time and filament savings compared to any kind of single or even dual nozzle AMS setup. I will try more color prints, starting with expanding my Hello Kitty army. When printing 4 at a time, regular single nozzle AMS setups would take between 17 and 20 hours. The estimated time on this printer is 9.5 hours, and the waste should also be minimal with just a small prime tower. The tool changing time across different prints is consistent at about 7 seconds. I am not sure when that squeaky sound disappeared, but it seemed to be gone near the end of the previous 4-color square print. The time difference seems to come only from the travel distance of the print head. When grabbing the last tool head at the bottom, it may take 0.2 or 0.3 seconds longer, but it is still around 7 seconds. The print finished in 9 hours and 7 minutes, about 20 minutes faster than the estimate. The filament usage is spot on. The model uses about 220 grams with a 20-gram prime tower. On a tool changer, there is no color contamination, and all 4 kitties are identical. Let's do some comparisons, starting with single nozzle AMS setups. Those machines finish the same print in about 17 to 20 hours, so the Creator 5 is basically printing twice as fast. The prime towers on all machines are not very different, at around 20 grams each. So, the total filament savings of a tool changer are significant, mainly because it does not need to purge any filament during color changes. When compared with a dual nozzle AMS setup like the Bambulab X2D, the X2D's filament waste is 39 grams, which is much less than a single nozzle setup that wastes around 200 grams. But of course, in terms of both time and filament savings, the Creator 5 is still the clear winner. When compared with the H2C and Snapmaker U1, the filament usage of all 3 machines is similar, while the Snapmaker U1 is still slightly faster, followed by the Creator 5. The H2C's hot end changing, including filament loading and unloading, still takes about 30 seconds, so the print time is slightly slower than true tool changers. Next, I will print the Vegeta model and compare with other machines. The estimated time is about 3 hours. When using a single nozzle AMS setup, this print would take 8 to 10 hours. The print finished in 3 hours and 2 minutes, which is in line with the estimate. The model itself is 21 grams, and the prime tower is 23 grams, so the waste is still minimal. When using a tool changer, the color changes are super clean, even though Vegeta is the king of color contamination on other AMS setups. When compared with single nozzle AMS setups, the print time is 2 to 3 times faster, and the total filament usage is also 3 to 4 times lower. When compared with more advanced machines, it saves more filament than the dual nozzle X2D and the hot and changing H2C. It is similar to another tool changer, the Snapmaker U1, but the overall printing time of the U1 is slightly faster. I will then print the Master Sword model. This is a tall print with 877 filament changes, but the estimated time is only about 9 hours, which is way faster than a single nozzle AMS setup that takes over 30 hours. On this print, I actually had a few failed attempts. I will include all of them in this video and show you how I finally printed it successfully. On my first try, the prime tower did not stick well enough to the bed. I wasn't next to the printer, so I stopped it after a while. Since the bed temperature was already set to 65 degrees Celsius, which should be good enough for any PLA, I applied some glue and restarted the print. However, the prime tower still did not stick well. When I inspected the bottom of the tower, I found that the first layer was not printed completely. The second layer white filament was printing on top of an incomplete first layer. Since the prime tower is small, it did not stick well, even with glue stick applied. I then applied even more glue and restarted the print, but the prime tower failed at almost the same height. So, I think the incomplete first layer on the prime tower is the real cause of these failures. When I went back to the slicer, I found that the first layer was not supposed to be half empty like the actual print. Somehow, the black and yellow filament in this area did not print as expected, making the first layer adhesion of the tower weaker than it should be. Then the second layer white filament printed on top of an incomplete first layer. This is probably why the prime tower failed 3 times in a row. For now, my fix is to print a larger prime tower by increasing everything I can in the slicer, including making it wider, increasing the prime volume, adding a wider brim, and increasing the flow when purging on the tower. This way, I am going to waste an extra 90 grams of filament on the tower, which is not ideal. But the worst outcome would be another failed print, and I already had 3 failures that wasted around 300 grams of filament. So I restarted again with this extra large prime tower. As expected, this time the print finished in 11 hours and 11 minutes without any issues. The model itself uses 108 grams, which is pretty accurate, and the prime tower is a few grams lighter than the estimate. Let's compare it with other printers. When compared with the dual nozzle X2D, it still prints about 22% faster. With the extra large prime tower, the filament usage does not have a big difference. The numbers in green are with the regular prime tower. I actually think this small tower should work if the first layer can print completely, but FlashForge may need to look into this issue and fix it at the slicer level. When compared to the AD5X single nozzle AMS style setup, the Creator 5 prints almost 3 times faster and still saves 3 times the filament, even with an extra large prime tower. When compared to the Snapmaker U1 and Bambu Lab H2C, the Creator 5 is supposed to be faster than the H2C and close to the U1, but it was slowed down and wasted more filament, mainly because of the extra large prime tower. If the smaller tower worked properly, it could potentially save even more filament, but it is what it is. At the current stage of this test unit, this is the only way I could finish this print after 3 failures. I will now try printing with different materials, starting with a PETG horse model with PLA support. My first attempt failed. As you can see, the layers of the prime tower didn't stick together. By default, the slicer won't print 2 different materials separately in the prime tower, or use one material as the wall for the whole tower. As a result, the PLA and PETG won't stick together, and that's the exact reason I wanted to use PLA as breakaway support for PETG. When I go back to the slicer, you can see in the preview that this tower is definitely going to fail, as there is no way you can use a mixed wall with different materials. This should be easy to fix. Instead of default, we just need to use PETG for the outer wall of the prime tower. So, even when we need to purge PLA in the tower, it will purge inside the PETG wall. I restarted the print. It printed normally for a while, however the machine suddenly paused. It showed an MCU communication lost error, and I just couldn't continue the print. As I already printed a few large models with multiple tool heads, I don't believe it's a tool changer issue, so I just restarted and checked if it would pause again. This time it also paused, but the error message was different. It showed extruder mount MCU communication lost. It's slightly different from the last one, and the only reason I could think of was the different printing temperatures of PETG and PLA. I printed PETG at 260 degrees Celsius and PLA at 215 degrees Celsius, which has a difference of 45 degrees, but when I previously printed multiple PLA models, they were at the same temperature. I then tried to print the PETG model with PETG support only, using 260 degrees Celsius, and it worked fine this time. So, I think one of the possible causes is the temperature difference. I then adjusted PETG to 245 degrees Celsius and PLA to 225 degrees Celsius to make the temperature difference 20 degrees and restarted the print. This time, the print had no issues and finished in 4 hours and 29 minutes. The model used 65 grams, and the tower used 20 grams of filament. The PLA support can be removed easily, and you can see the bottom of the horse looks very clean. The model printed okay and worked as expected, but a 45-degree temperature gap between two filaments causing an MCU connection issue doesn't make much sense to me. However, I will move on to other prints, as I don't want to get stuck on this issue. I will then print a chain with PA12 nylon carbon fiber with ABS support. The PACF is set to 280 degrees and ABS is set to 260, so the temperature difference is naturally minimal for this combination. When switching tool heads between different types of filaments, the time is also very consistent at around 7 seconds. This print finished in 1 hour and 30 minutes. I didn't dry the PACF before starting this print, but it was stored in a camera dry cabinet. The condition may not be perfect, but I think the result is acceptable. I can simply take out the chain from the ABS support, and the overhanging areas are quite clean as well. I will do one more multi-material test before I move on to my benchmark prints. This time, I will print a PETG Jeep with TPU tires and use PLA as support. I try to keep the temperature difference around 20 degrees. I set PETG at 245 degrees and PLA and TPU at 225. It may be a little bit high for this Eryone TPU, as I normally print it at 200 degrees Celsius or 205 degrees Celsius, but the flow rate of TPU is only set to 3.2 cubic millimeters per second, so it will just print at a very slow speed at 40 millimeters per second. The print finished in 6 hours and 55 minutes. It printed mostly fine, except for the stringing with TPU. The probable cause is that printing these wheels is similar to printing two TPU objects at the same time. The extra travel movement of the extruder, combined with the slightly higher nozzle temperature, likely resulted in more oozing and increased stringing. I just rubbed them off with my fingers, and it's not too bad. The PLA support is super easy to remove, and the Jeep is a usable and playable print. As I said before, a 45-degree temperature gap between two filaments causing an MCU connection issue doesn't make much sense to me. So, I printed the same model again and tried PETG at 255 degrees and PLA at 210 degrees, with the same 45-degree temperature gap. However, this time it printed normally. For now, I have no logical explanation for those two failed prints with similar MCU connection errors. I just exported the log file from the printer and sent it to FlashForge so they can figure out what caused that glitch. Okay, let's move on to my benchmark prints, starting with the number slider for the clearance test. it finished in 2 hours and 20 minutes, about 12% faster than the average 2 hours and 45 minutes printing time. The top looks alright, the texts are clear, with just very minimal stringing. The bottom looks very nice, and there are gaps between the tiles. All tiles can move freely. Next, it will be the tolerance test to see if the parts can fit together. This simple model took 1 hour and 10 minutes, about 20% faster than the average 1 hour and 30 minutes print time. On the square side, it can almost clear the tightest 0.05 millimeters and stops at 0 clearance. On the cylinder side, it clears the tightest 0.05 millimeters and stops at 0. It's a perfect result on the cylinder side and almost perfect on the square side. The results suggest further pressure advanced tuning may be required. Then, it will be the Honeycomb box test for extruder retraction. The extruder can extrude a tiny bit of filament, retract right away, and move to the next spot. This print finished in 2 hours and 19 minutes. As this small print has no room for acceleration at all, it is just 9% faster than average. The honeycomb patterns are clean, with almost no stringing, and all patterns were printed successfully. Let's compare it with other printers. It's on par with some good quality printers I have tested, and I have no complaints about this print. Up next, it will be the Robo Alpaka from Prusa for the surface quality test. This print finished in 4 hours and 7 minutes, about 8% faster than the average 4 hours and 30 minutes. However, the surface quality is not good. It's usable, but not as good as other well-tuned machines. When compared with the Bamboo Lab H2C, the H2C is 7 minutes faster, and the surface quality of the H2C is a clear winner. When compared to the Snapmaker U1, the times are almost the same, but the surface quality of the U1 is also a clear winner. When compared to FlashForge's own entry-level single extruder AMS setup, the AD5X, the Creator 5 is slightly faster, but the surface quality of the AD5X is better. When compared with the Bamboo Lab X2D, the X2D is a few minutes faster, and the surface quality is also much better. It seems the Creator 5 input shaper didn't work too well at the current stage. As a Core XY machine, it still works better than bed slingers like the Sovol SV06 Ace, but it definitely falls short when compared to well-tuned Core XY machines. Finally, I will print a PLA sheet for the first layer and Auto Z offset test. At first glance, the first layer looks okay, and it should be usable for most prints. However, when zooming in, the lines are not close enough to each other, suggesting the Auto Z offset is set a little too high. As expected, the lines separated when I tried to peel it off from the print surface. I used another tool head and printed one more PLA sheet and let it redo the bed leveling. The result is similar. It's also usable for most prints, but when zoomed in, the lines are not touching each other, and they just separated when peeled off. So, the offset between tool heads is good, but the Auto Z offset is too high and also needs further firmware tuning. Let's talk about the pros and cons of this printer, starting with the pros. 1. The tool changers worked flawlessly. The tool changing time was around 7 seconds across different prints and materials. The results were very consistent. I did have some failed prints, but none of them were related to tool changing errors after almost 3,000 tool changes during my testing. 2. The X, Y, and Z offset calibration uses the exact same approach as the Snapmaker U1. It has a disc-shaped metal piece for nozzle offset calibration, so you don't need an alignment pin that screws into the bed, which may be easy to lose over time. I only did the calibration once, and it completed all the prints you saw in the video, as well as some additional off-camera prints. 3. For leveling and Z offset, it uses an additional nozzle for probing. This can avoid errors caused by filament residue sticking to the nozzle. The hardware design idea is good, but there were some firmware glitches that I will discuss later. 4. The spool holders use the most basic plastic design instead of the spring-loaded ones on the Bamboo Lab A series and Snapmaker U1. I actually like this simple design more, as I can use almost any type of filament spool. With some spring-loaded machines, Prusa spools fit too tightly, while some other spools may have a larger center hole, but this simple spool holder just accepts them all. 5. Print speed is relatively fast. It's not the fastest, but on single filament benchmark prints, every single print was faster than the average time of the latest generation printers. The clearance, accuracy, and extruder retraction all worked well, except the input shaper needs further tuning to improve surface quality. Now for the cons. 1. More firmware tweaks are also required. For example, the input shaper did not work well. As the surface quality test came out below average, the tolerance test was better than average, but not perfect, as it could not clear the tightest 0.05mm tolerance on the square side like some well-tuned machines, since it clears the cylinder side without issues, so it should mainly due to pressure advanced tuning. When printing different types of filament, such as PETG at 255 degrees and PLA at 210 degrees, the MCU connection error sometimes appeared in the middle of the print. I did have successful prints with the same temperature gap, but there was no clear sign of why the MCU disconnected repeatedly during the same print. However, I never saw similar issues when printing multiple PLA models, even on long prints over 11 hours. The Auto Z offset was also set a bit too high by default. It didn't pass the first layer test, as the lines separated when I peeled it off from the print surface. 2. Some glitches in the slicer also need to be fixed. For example, when printing different types of materials, the prime tower should use a single material as the outer wall by default. It would be even better if different materials could print separately inside the tower, like what Bamboo Studio and some other skin slicers, such as Cheetah Studio, do. The device tab may also show the printer as offline if it has been idle for a while. You have to press the Add Printer button, click on the Creator 5, and the slicer will show it back online. 3. Filament loading and unloading are manual. You need to push the filament all the way to the extruder. When unloading, you need to manually press down the filament cutter to cut it off, then pull the filament out. For some people, this is not necessarily worse than the SnapMaker U1's automatic loading feature, since you do not need to wait for the nozzle to heat up, and you can generally load and unload filament much faster with this simple manual operation. There is also no RFID reader on this machine, but for me, I use random brands of filaments anyway, so it won't be an issue for me. However, using fewer motors and without the RFID reader does reduce manufacturing cost. 4. For other small improvements, it needs better formatting for on-screen dialogues, such as the summary screen after a print is finished. I have been mentioning this since the AD5X. Also, bed leveling before a print should only probe the printing area instead of redoing the entire 10x10 grid. In conclusion, the Creator 5 and the SnapMaker U1 both feel like more refined, more consumer-friendly versions of the Prusa XL with the 3D printed parts replaced by injection molded parts. Compared to the SnapMaker U1, the Creator 5 is $100 cheaper, more compact, and has stronger specs in some hardware areas, including a high-temperature 320-degree nozzle, a 120-degree bed, a linear rail on the X-axis instead of carbon rods, 5 GHz Wi-Fi support, and a larger 4-inch touchscreen. However, it also has a 15% smaller build volume, a slightly slower 1 to 2 second tool changing time, no motors for automatic filament loading and unloading, no RFID reader, no filament drip tray, and simple plastic spool holders instead of spring-loaded ones, and a lower resolution camera. So, the Creator 5 wins in some hardware specs, especially printing temperature, while the U1 has a larger print volume and more convenient features. Since the U1 was released last year, it has already gone through several rounds of updates, so the firmware is also more reliable than the Creator 5 at this stage. Personally, I don't think a $100 price difference gives the Creator 5 a huge price advantage as a newcomer, especially with its smaller print volume. But if the price gap becomes larger, it would become much more competitive. The Creator 5 is currently the lowest priced tool changer on the market, and the hardware, especially the tool changing system, works exceptionally well. I think FlashForge has a very strong product here. They are a well-established company, so I don't think fixing these firmware issues should be a major problem for them. That said, it would have been better if these issues had been resolved before the test unit was sent to me. If FlashForge fixes the firmware glitches and gives the Creator 5 a slightly stronger price advantage over the Snapmaker U1, I would definitely add it to my recommendation list on my website auroratechchannel.com. By the way, I may also test the Creator 5 Pro in the future depending on my schedule. It is a fully enclosed version with a door and back panel, a heated chamber, a multi-stage filter, and an auxiliary fan, and it costs another $150. If you are interested in the FlashForge Creator 5 or Creator 5 Pro, I put the links to both machines in the video description below. Don't forget to also check out AuroraTechChannel.com, which tracks prices for popular 3D printers, laser engravers, and CNC machines to help you find the best deals. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.